Bum, bum, bum. All right, cool. So number 4 is the long one. It's a word problem, so I'll read it out to you. Ricardo is making an open-top box by cutting squares out of a corner piece of paper that is 15 inches wide by 18 inches long, and then folding up the sides. So there's these little corners. These little things are X by X. And then it says the side lengths of the square cutouts are X inches. Then the volume of the box, and it gives it to you. So we say, thank you, problem, for giving us this volume. And we take this and we go 15. This is exactly what it says. The volume of the box is X times 15 minus 2X times 18 minus 2X. Now this is because when you fold up the sides, it's going to be X height. X is going to be the height because it's the length of the slit. And then we cut out of 15 an X here and an X here. So that's 2X. And then we did the same thing for 18, that side. And then we multiplied the lengths of the sides to find the volume. So it didn't come out of nowhere. He then said he graphs that along with a function of b of x equals 120. Now, b of x equals 120, that did come out of nowhere. There is no explanation for what that necessarily is. So this is b of x. And then this red curving line in the problem is v of x. This is about 200. And then this is 0. This is about 2. 4 is about here. 6. And you can look at this graph on your paper, and it'll be more accurate than my little hand drawing, right? First question. What is a reasonable domain for v of x? Well, domain is all possible, I'm sorry about my handwriting, all possible x values. So, x in this case is what? Well, it's how much we've cut out of this little piece of paper. So at what point could you stop cutting piece of paper? For me, I'd say, well, if we got x to be like this big, this is x and this is x, and then on the other side it would also do x and x, we run out of paper. That's where it doesn't make any sense. So, specifically to see where that happens at, we can look at our equation, right? 15 minus 2x. When x equals 15 divided by 2, because we're going to have to multiply by 2, that's its absolute maximum. We've cut up all the paper then. So we can write here, right? X is going to be less than 15 over 2, which is 7.5. But either one would have been fine. Now, we have to ask ourselves, can we cut negative out of this box? If I asked you to cut a negative length, could you do that for me? No, you can't. Negative lengths don't exist, or at least if they do in a theoretical concept, I don't know about them. So, here we go. This is then what we have. Because you can't cut negatives of this box, and you can't cut any more than the length of the entire sheet. All right, that's question, answer number A, part A. Approximately which value of x will give him a box with the greatest volume? So remember, we have this graph here. This is the volume. It told us that. So we just got to look, where is that number the biggest? And it's a little trick because we already said that 7.5, which is right about here, is where this stops making sense. So you can't select anything to the right of this. Instead, we go, all right, that's where it probably looks the tallest, and that's about 3. That's it. About 3. Part C, for which values of x is the volume of the box increasing? So what does increasing mean? Increasing means going up. So let's look at it. It's increasing from 0 to 3. You could also say it's increasing over here from about 7 to whatever, but that it's talking about the volume of the box, not just the equation. So we say from 0 to about 3. That's all you need. Just show me that you know that concept. D, what do the points of intersection between these two graphs represent? So these points of intersection here, I can use different colors, are here and here. So V of x, we remember, is the volume. B of x, they didn't say anything about except that it's equal to 120. So when the volume, right, when this V of x equals B of x, it means the volume of the box is 120 inches cubed. And I won't even fault you for using the sort of wrong units there. I'm not even sure if it gives you... Yeah. The volume of the box is 120. It is inches cubed, but I'm not going to fault you. Take time. Make sure with graph problems that you just take it slow and do whatever you can. I can only grade work that you show me.